So in the last class, we were talking about center of mass, and I told you that to deal with continuous objects, uh, we have to use x cum is equal to integral of x dm divided by integral dm, and y cum is equal to integral y dm divided by integral dm, right? And we did for the half ring, right? Half ring के लिए किया था ना हमने? Yes, no, yes, हाँ किया था ना, half ring के लिए किया था. And I told you that we are going to derive certain things which is not, I'm not giving you a question, it is a part of the theory. It will be very nice if you can derive it yourself. And of course, if you cannot, I will do it. But in either case, uh, the result has to be remembered. So number two is the center of mass of a half disk of mass m, radius r. So this is the x-axis, y-axis, and this is the half disk. Right? So you have to find the center of mass of this. So we know that x um is equal to integral x dm divided by integral dm, and this will be equal to how much? Do I need to carry this out? Very good, Abhijit. So I don't even need to carry this out because, sorry, people say, like we discussed, like we discussed, if an object is symmetrical and uniform, and it is symmetrical about the y-axis, then the x-coordinate of center of mass will be 0. And if it is symmetrical about the x-axis, then the y-coordinate of center of mass will be 0. So in this case, this object is symmetrical about the y-axis, therefore the x-coordinate of center of mass is. इसका मतलब सिंपली ये है कि अगर यहाँ पे एक पार्टिकल एग्जिस्ट करता है जिसका एक पर्टिकुलर एक्स कोऑर्डिनेट है, तो डेफिनेटली माइनस उस पर्टिकुलर एक्स कोऑर्डिनेट पे भी एक सेम पार्टिकल एग्जिस्ट कर रहा होगा, राइट? एंड व्हेन यू कैरी आउट m1 x1 plus m2 x2, this will give you 0. Okay? Now we need to find the y coordinate of center of mass. To find the y coordinate of center of mass, what we are going to do is this. Y coordinate of center of mass is equal to integral y dm divided by integral dm, where y is equal to the y coordinate of the center of mass of the chosen element. So now we need to think how or what is the element of a half disk. What is the element of a half disk? So first let me show you the wrong choices. If you think, बिल्कुल सही. If you think that you can take this as the element of the half disk, then you would be mistaken, because if you do, then you would end up with a horrible, horrible thing, which fortunately you don't have to study in class 11th and 12th, right? So if you take this as the element, then this will become dx and this will become dy, and you will end up with something having an area which is equal to dx dy, which you cannot handle. Okay? So this cannot be done. This is not a viable choice of element. Now, you may say that, look, let me choose something like this, theta, d theta. This is also not a viable choice because you do not know the y coordinate of this blue object. And to find the y coordinate of center of mass, you must know the y coordinate of center of mass of the chosen element. So if you choose an element like this, you do not know where its center of mass is, and you will sort of end up, first working out the center of mass of this chosen element. उसके लिए पता नहीं क्या करना पड़ेगा. So this would be futile. This would be incorrect. Right? So since center of mass of chosen element is unknown. ठीक है? Yeah. So what should I do? I can't choose a point particle to be the element of this object. I can't choose this blue thing to be the element of the object. Yeah, so how is this object made? I've told the story before. I will tell it again. Later on, I will tell it again. So I take a marble and I paint the marble white. Okay, uniformly I paint the marble white, and then I leave it for one day for the paint to dry. Then I come back the next day and I paint it blue and I leave it. And then I come back the next day, I paint it pink and I leave it. And I come back the next day, and so on and so on and so on. Every day I come back and I paint a different color and I leave it for a day. So, what would happen after, let's say, 100 years of this experiment? Well, after 100 years, the marble would not be the size of the marble that I started with. Okay, the object would be now having, the object would still be a sphere, but the radius of the sphere would be larger as compared to that of a marble. Right? Maybe it will be like a football now. But remember that every day I have painted it in different color. Okay? So after 100 years, when I have a sphere the size of a football, I decide to cut it down the middle. Okay? I decide to cut it down the middle and I show you the cross section. When you see the cross section, can you visualize what you will see? When you look at the cross section of this sphere, can you visualize what you will see? क्या दिखाई देगा हमको? What will we see? Yes, very good. Yes. Yes, completely white क्यों हो जाएगा भाई? So when I cut the sphere, I will see extremely thin circles. When I look at the cross section, I will see extremely thin and innumerable circles, one for each. Very good issue. So I will see innumerable circles, one for each day that I have painted on the marble, and different color circles uh, uh, making the cross section. So the cross section would be sir, बिल्कुल sir. So I'm just making a diagram of a part of the cross section. So something like I will see something like this, and each individual layer, each individual layer would be extremely thin, right? It would be equal to the thickness of the layer of the paint. Okay, so let's imagine that I have put the two hemispheres back together. I have put the two hemispheres back together, and now I'm going to do something which is impossible physically. Okay, this is the physically impossible. Yet I'm going to do it. So after 100 years of painting the marble, what I do is that I look at the outermost layer of paint. Let's say it is white. So what I do is I take out that layer of paint. Physically impossible. It is only a mental exercise. I take out the layer of paint such that the layer of paint does not lose its integrity. It is not torn or it is not ripped from any side. Okay, I said physically it is impossible. I'm just doing it mentally. So if I take out the white outermost layer of paint, what will I get? I mean, what am I holding in my hand? If I take out the outermost white layer of paint, what am I holding in my hand? I will be holding a still a sphere, absolutely right, a white sphere in my hand. But what will be the thickness of this sphere? What will be the thickness of this sphere? The thickness of the sphere will be negligibly small. The thickness of the sphere will be negligibly small because all I'm holding is like a bubble of paint. Okay, it's a very thin layer of paint. And then I find that the next layer is a yellow layer, and I take that out as well. And then I find that the next layer is an orange layer, and I take that out as well. And I take out now all the layers of paint that I have put for the past 100 years, and I take a very long straight bench, and I keep all these spherical layers of paints on this bench adjacent to each other. Okay? सबसे पहले वो व्हाइट लेयर आएगा, उसके बाद से येलो लेयर आएगा, उसके बाद तीसरा लेयर आएगा, फिर चौथा लेयर आएगा, until of course at the very end of the bench the marble is there. What can you tell me about the radii of two adjacent spheres? If you look at, तो मैंने सब कुछ बेंच पे अरेंज कर दिया है और मैंने आपको बोला कि भाई ये दो देखिए, ये दो आजू बाजू हैं, तो इनके इनके रेडियस के बीच में आपको रिलेशनशिप क्या समझ में आएगा? Yeah, exactly. Very good, Radhika. Yes. So when we look at two adjacent spheres, we will say that their radii are same, okay? Almost the same. In fact, our eyes will not be able to distinguish whether the radii are different or not. For us, for our senses, it will be same. So if two adjacent spheres have the same radii anywhere you look on the bench, right, or at least they appear to have the same radii, what can we say about the radii of a sphere which is near the white sphere compared to the radii of a sphere which is near the marble? Now we can definitely compare. Visually, we can see that the radii of the sphere near the white sphere is large, whereas the radii of the sphere near the marble is small. वो शायद सेकेंड ईयर के पेंट का लेयर है और ये शायद 98th ईयर के पेंट का लेयर है, तो ये बड़ा है और वो छोटा है. So a solid sphere then for us mathematically is made up of an infinite number of hollow spherical shells. Always in physics, a solid sphere for us is made up of an infinite number of hollow spherical shells placed one on top of each other and their radii being infinitesimally greater as we go outside. So that means that one layer of paint, the green layer of paint, supposing उसके बाद जो है हमारे पास पर्पल लेयर ऑफ पेंट है, तो ग्रीन लेयर ऑफ पेंट और पर्पल लेयर ऑफ पेंट में जो रेडियस का डिफरेंस होगा वो इनफाइनाइटिसमली स्मॉल होगा, राइट? द आउटर लेयर विल हैव very small increment of radius from the previous layer. ये आ रहा है सबको समझ में? Everybody is able to visualize what I am trying to say. So mathematically, whenever we see a solid sphere in physics, we will consider the solid sphere to be made up of an infinite number of hollow spheres. Let's look at the cross section now. When we look at the cross section, now you can answer my question. Mathematically, in physics, whenever you see a disk, then the disk will be made up of what? What will be the elements of a disk? What will be the elements of a disk? Oh, bhai, what will be the elements of a disk? A disk हेमिस्फीयर से नहीं बन सकता है ना? हाँ विजित, बिल्कुल सही. ये मैंने डायग्राम बना हुआ है स्क्रीन पे है आप. हाउ इज अ डिस्क मेड, राइट? सो ये क्या चीज, व्हाट इज दिस? दिस इज दिस. हाँ जोहेब, डिस्क आप स्फीयर से नहीं बना सकते ना जोहेब, दैट वुड बी इम्पॉसिबल, राइट? इफ आई गिव यू फुटबॉल एंड बास्केटबॉल और मैं आपको बोलूँगा आप इसे डिस्क बना दो, तो आप वो नहीं कर पाओगे ना. So this is equal to this plus this plus this plus this. Plus this. Yeah. So any linear object is made up of point elements. The element is a point particle. any linear object, the element is a point particle. For a disk, the element is always a ring. Okay, and you take the radius of the ring as small r, and therefore the thickness of the ring will be dr. Okay, and for the same diagram, solid sphere is made up of a large number of hollow spheres. Again, the diagram will be same. Right, so let me write this. Linear objects, elements are point particles. This is made of uh, concentric rings of increasing radius. Sphere, solid sphere, is made of um, hollow spherical shells of increasing radius. Yeah. So here we use dm is equal to lambda dx, or dm is equal to lambda rd theta. Here dm is equal to sigma into the area of blue ring. Can you tell me the area of the blue ring? याद है क्लास 10th में वो पढ़ते थे क्या, सा चैप्टर होता है मेंसुरेशन, ऐसा कुछ होता है, एरिया एरिया निकालना होता था ऐसा कुछ. Okay, I'll हाँ, if we have not discussed, last class में discuss किया था ये कुछ. Imagine, हाँ सत्य, very good, excellent, yes. I will tell you a better method. So what these guys are saying, that pi into r plus dr whole square minus pi into r square, that give us the answer. That is absolutely correct, of course, absolutely correct. But I will give you a more superior way of thinking about this, right? And everybody should think like this. Supposing that I take this ring and I cut it from here. Okay, I take this blue ring and I cut it from here and I lay it out flat on the table. So I lay it out flat on the table like so. If I do that, then it will look like a rectangle. What will be the length of the rectangle and what will be the width of the rectangle? What will be the length of the rectangle and what will be the width of the rectangle? Right? So the length of the rectangle would be equal to 2 pi r, because it would be equal to the circumference of the circle, and the width of the rectangle would be equal to dr, because that would be equal to the thickness of the ring, and therefore we will get is equal sigma 2 pi r dr. Okay, and for a solid sphere, we are going to get dm is equal to rho into the volume of the spherical shell. Okay, and I'll tell you how to find the volume of the spherical shell. So, volume of shell is nothing but the surface area of the shell multiplied by the thickness of the shell. After all, volume तो आप ऐसे ही निकालते हो, area multiplied by thickness. L into B into H. L into B is the area, H is the thickness. So here we say that uh, notes देखो ना विश्वजीत अपना. So dm would be equal to dm would be equal to rho into surface area of the shell into बताओ विश्वजीत जल्दी बताओ आंसर बताओ मेरे को ये पूछा है क्वेश्चन आपने look at your notes tell me the answer so this is very important good boy yes so this is very important this is what we are going to use this is the crux of the maths that we are going to use please take a screenshot or please write this down that will be better please write this down. Okay, so now let's try this question. Let's try this question again. Let me do it on a new page. Center of mass of a half ring of radius r and and mass m. I don't really need the mass. So on the xy axis, we have the half disk, and we know that the x coordinate of center of mass is we have to find the y coordinate of center of mass, which is integral y dm divided by integral d. Step number one, I have to choose the element. What should be the element here? Based on what I've just told you, what should be the element here? Very good, Abhijit. Yes. The element should be a half ring. The element should be a half ring. Then I have to decide on the radius of this chosen element. Remember, this is arbitrary. I can choose y dy or x dx or r dr or l dl, whatever I want. I will choose small r, and therefore the thickness is dr. Okay, so this is the element, and this is for the first time we are choosing an element which is not a point particle, right? This is what you have to learn today. We are choosing for integration an element which is not a point particle. So the half disk is made of half rings. Okay, now, once I have chosen the element, everything else remains the same. So I've chosen the element, I have introduced a new variable and a corresponding d term. And now I'm going to place everything in the equation for the y coordinate of center of mass. This is equal to integral of y coordinate of the chosen element center of mass. Now, if I had chosen a point particle, then the location of the point particle would be the y coordinate. यहाँ पे जो भी मैं y coordinate लिखता, that would be the y coordinate of the location of the point particle. But I have chosen an element which is a half ring. So I must write down the y coordinate of center of mass of a half ring. Fortunately, in the last class or in the last step, that is what we have found. So what is the y coordinate of center of mass of a half ring? What is the y coordinate of center of mass of a half ring? केवल अभिजीत सत्यम आंसर करता है और राधिका करती है, और कोई नहीं. बाकी Sveta, 2r by pi. So we have 2 into radius divided by pi into dm. Now, since this is a two-dimensional object, we must use mass per unit area. Okay. Pi constant, मतलब रजत क्या पूछ रहा है, नहीं समझ में आया मेरे को. क्या पूछ रहा है रजत? हाँ, बाहर निकाल दो. हाँ हाँ, यस यस, बाहर निकाल, अभी नहीं निकालते हैं, बाद में निकालते हैं. जोहेब लास्ट क्लास में ये डिराइव किया था ना, लास्ट क्लास का देखो जोहेब, नोट्स देखो. Sigma into the area of the half ring. Let me not write it like this. Let me write the value of the area of the half ring. So what will be the value of the area of the half ring? Remember the tool that I taught you, इसको सीधा कर दो, इसको उठा के सीधा कर दो. सीधा किया तो ये रेक्टेंगल बन गया. ये रेक्टेंगल का एरिया क्या होगा? Please tell me the area of the rectangle of the blue this thing. नहीं सोनल, गलत आंसर है. क्यों है गलत आंसर? क्योंकि ये पूरा सर्कल नहीं है ना, आधा सर्कल है ना. तो इसका पेरीमीटर होएगा पाई आर इंटू डी आर डिवाइडेड बाय integral of sigma into pi r dr. Sorry. So let me just write down what are the things that I have written here. So this guy is the y coordinate of center of mass of element. This guy is mass per unit area, and this is area of chosen blue half ring. Let me just put some brackets. So this is a bracket. This is okay. So this will become, अब यहाँ पे क्या होएगा, पाई और पाई तो कैंसिल हो जाएगा, सारे कांस्टेंट्स को बाहर कर दे रहा हूँ मैं, तो ये हो जाएगा 2 सिग्मा इंटीग्रल r स्क्वायर dr divided by pi sigma integral r dr. Okay, please remember that you can cancel out the sigma but you cannot cancel out the r. ये कभी काम मत करिएगा, बिकॉज ये r स्क्वायर dr इंटीग्रल साइन के अंडर में है. okay? वहाँ पे ये कैंसलिंग आउट अलाउड नहीं. फॉर द फाइनल स्टेप, for the final step, for the final step, I have to choose the limits of integration. लिमिट्स ऑफ इंटीग्रेशन के लिए मुझे वो एलिमेंट देखना है जो सबसे छोटा है और वो एलिमेंट देखना है जो सबसे बड़ा है. वो एलिमेंट देखना है जो सबसे छोटा है और वो एलिमेंट देखना है जो सबसे बड़ा. बेसिकली I have to look at elements that lie at the extremes, and then I have to decide the value of the variable, in this case small r, for this for this for these extreme elements, right? So again I will choose the marker thingy. Good boy. Yes. नहीं समझ, गलत प्रातिका गलत. So this has, so this has a radius of 0 and this guy has a radius of r. नहीं जो है क्या कर रहा है. So the limits of integration are 0 to capital. Right? It's just like the marble and the layer of paint. What will be the radius of the innermost layer of paint? Well, it will be equal to the radius of the marble. And what would be the radius of the outermost layer of paint? Well, it will be equal to the radius of the final sphere that I get. Okay. So this will be equal to 2 by pi into r square का integration r cube by 3. Okay, एक step मैं खा गया. Let me just go back. So this will be r cube by 3, 0 to r, divided by r square by 2, 0 to r. This would be equal to 2 upon pi into r cube by 3 divided by r square by 2. अब हम कैंसिल आउट कर सकते हैं. जब इंटीग्रेशन हो गया, सब कुछ हो गया, अब हम कैंसिल आउट कर सकते हैं. So therefore, y coordinate of center of mass is equal to 4r by 3 pi. कौन सा पाई कैंसिल हो गया वो है, किसके पीछे पड़ा है तू? ऊपर वाले एक्सप्रेशन में पाई कैंसिल हुआ ना, नीचे वाले एक्सप्रेशन में तो पाई नहीं कैंसिल हुआ ना, पाई तो है ना. 3 पाई आया ना पूरे पूरे उसमें, उसमें कि 2 कैंसिल हो गए, एक बच गया. प्लीज राइट दिस डाउन. सिग्मा की वैल्यू होगी m अपॉन pi r square by 2. If you are interested, the value of sigma will be equal to m upon pi r square by 2. क्योंकि हाफ डिस्क का एरिया पाई आर स्क्वायर बाई 2 हुआ, मास उसका m है, मास अपॉन एरिया. चलो नाउ, हाँ, now for the, I'm going to change the slide. Okay, please take a screenshot. लास्ट क्लास में हमने y कोऑर्डिनेट भी निकाला था जोहेब. y कोऑर्डिनेट नहीं निकाला था रिंग का हमने लास्ट क्लास में, हाफ रिंग का. सॉरी, anyone, last class में did we find the y coordinate of the half ring? निकाला था ना. जोहेब क्या कर रहा था? आएंगे होंगे, आएंगे, नॉन यूनिफॉर्म पे भी आएंगे, भी आ रहे हैं. So now your step, okay, please see if you can do this. Center of mass of a hemispherical shell of radius r. I will draw the diagram for you. This is the XYZ axis, and this is the hemisphere. Please find, try this yourself. Try this yourself. I'll give you 5 minutes. Choose an element. Okay. What element to choose here? This is the real problem. And if you can choose an element, then the next problem is that where should the or what should the variable be? या मैं वो बता देता हूँ रुको मैं बता I will tell you what the element should be. मैंने कोई 3D एंगल कुछ नहीं करेगा देखो so this is the hemisphere. Yeah. So this hemisphere is made up of rings. How do you make a hemisphere from rings? Well, what you do is you take a big ring of radius r, and on top of that, you place another ring having a slightly smaller radius. On top of that, there's another ring having another slightly smaller radius. On top of that, you place another ring having slightly smaller radius. And you keep on doing this. Okay? You keep on doing this until ये आया समझ में सबको कैसे ये हेमिस्फीयर बन रहा है दिस इज अंडरस्टूड ये बहुत जरूरी है समझ that this hemisphere is made out of rings which are kept on top of each other आया सबको समझ में ये anybody not understanding please tell me I will try to explain it again so how do I locate this ring that's actually very easy say that this angle is theta and therefore this angle is theta. Let me try to make a normal two-dimensional diagram. Actually, three-dimensional, but normal. So this is the center of the ring, of the red ring that we have chosen arbitrarily. The radius of the red ring can be found from the right-angled green triangle that I have drawn. The hypotenuse of this green triangle that I have drawn will be equal to radius of the hemisphere, and therefore, this length will be r cosine theta. This length will be r sine theta because this angle is theta. That means this angle is also theta. Right? This distance is r. Now, can you do this? अर्जुन की तरह आपको अब केवल ये रेड रिंग दिखाई दे रही है। अर्जुन की तरह अब आपको केवल ये रेड रिंग दिखाई दे रही है। और अगर आपको केवल ये रेड रिंग दिखाई दे रही है तो y coordinate of center of mass is integral of y coordinate of center of mass of the red ring multiplied by mass of the red ring divided by integral of mass of the red ring. Okay, so look at the red ring. Look at the red ring and try to find the y coordinate of the red ring. Try to find the mass of the red ring. Mass of the red ring will simply be equal to sigma multiplied by this area. This area you can find by again by that trick that I told you. यहाँ पे आप ये रिंग को सीधा रख दो टेबल पे. I'll give you 2 minutes. Try it out. Tell me the answer. All of you should try. गलत हो, सही हो, बिल्कुल ही गलत हो, कोई फर्क नहीं पड़ता. You are training your mind to do something. What are you training your mind to do? You are training your mind to apply calculus to a physical situation. So we have chosen an element. We want to find the center of mass, y coordinate of center of mass of this hollow hemisphere of radius r. तो मैंने तलवार से 2 बार हॉरिजॉन्टली कट मारा. जब 2 बार हॉरिजॉन्टली कट मारा, वन स्लाइटली बिलो द अदर, तो मेरे को एक रिंग मिला, बहुत ही पतला सा रिंग मिला. उसको लोकेट करने के लिए मैंने एंगल थीटा यूज किया है, एज आई हैव शोन. So now, just like Arjun, you can only see the red ring. Find the y coordinate of center of mass of the red ring. Find the mass of the red ring. To find the mass of the red ring, you need to find the area of the red ring. To find the area of the red ring, just apply the trick that I taught you. रेड रिंग को एक पॉइंट से कट किया और टेबल पे फ्लैट लेआउट कर दिया. जैसे ही फ्लैट लेआउट किया, मेरे को ये रेक्टेंगल दिखाई देने लगेगा, और रेक्टेंगल का एरिया मुझे मालूम है, लेंथ इनटू ब्रेड्थ होता है. डू दीज स्टेप्स. नहीं, ये इसमें पॉसिबल नहीं है ना. मतलब आपने जो लिखा है उसके यूनिट्स क्या होंगे. पाई आर क्यूब आपने बोल दिया, तो मीटर क्यूब हो गया ना. ऐसा नहीं पॉसिबल है ना. इस फ्लैट का एरिया 1000 मीटर क्यूब. That does not make sense, right? हाँ हाँ आएगा, बिल्कुल आएगा। यस। नहीं नहीं, एक ही वेरिएबल सोनल। अब ज्यादा वेरिएबल लेंगे तो फिर तो इंटीग्रेशन ही नहीं कर पाएंगे ना। दो वेरिएबल का इंटीग्रेशन आता है आपको? Therefore only one variable at a time. नहीं सत्यम, थीटा के टर्म्स में आंसर नहीं आ सकता है। नहीं नहीं नहीं, थीटा इज नॉट ए कांस्टेंट, थीटा इज अ वेरिएबल। वो अभिजीत ऑलमोस्ट करेक्ट। नहीं आई थिंक करेक्ट है अभिजीत, जहाँ तक मुझे याद है सही है। थीटा के लिमिट्स नहीं मिल रहे हैं। ओके, so let's look at the biggest ring there is. Okay, let's look at the biggest ring there is. The biggest ring must be this one, जो बिल्कुल बेस पे है। उसके लिए थीटा की क्या वैल्यू होएगी जो है बताइए? वेरी गुड राधिका, यस। जो है नहीं, थीटा की वैल्यू चाहिए जो है 2 पाई थीटा की वैल्यू। थीटा तो ये एंगल है, ये वाला एंगल। तो सबसे बेस वाली रिंग है, इसके लिए थीटा की क्या वैल्यू होगी? बताओ जोहेब। try to try to think of the thing as this is the hemisphere, right? So this is one ring, this is another ring. We are looking at it from the side. This is another ring, this is another ring. So what we have decided is that this is the variable, this is the variable, ये एंगल थीटा, ये एंगल डी थीटा, तो ये आर डी थीटा। अब बताओ जरा, ये बेस के लिए एंगल थीटा कितना हो जाएगा? 0। और सबसे टॉप वाली रिंग ये रही, इसके लिए एंगल थीटा कितना हो जाएगा? 5/2। वेरी गुड। नहीं 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 x coordinate of center of mass तो zero है ना. चल, so let me do this now. माइनस टू बाई पाई नहीं आ सकता ना, आर पे डिपेंडेंस रहेगा ना. आई एम गोइंग टू गेट रिड ऑफ दिस डायग्राम. मुझे अच्छा नहीं लग रहा. चल, everybody please pay attention. Y coordinate of center of mass will be equal to integral of y coordinate of the chosen element, which is r sine theta. Okay? I told you, just like Arjun, you're not looking at anything else, you're looking at the red ring. And if you're only looking at the red ring, okay, if you're only looking at the red ring, then the center of the red ring is here. This y coordinate from our origin is r sine theta. Into dm, which is sigma multiplied by area of the red ring. Area of the red ring must be the circumference of the red ring, which is 2 pi r cosine theta multiplied by thickness of the red ring, which is rd, divided by dm, which is nothing but a repeat of what I have written above. इसीलिए dm को हम dm ही रहने देते हैं. इंटीग्रल dm को सीधा कैपिटल M भी लिख सकते हैं, बट उसका कोई पॉइंट नहीं रहेगा. So what are the things that I can take out from the above portion? Sigma into 2 pi r cube. In fact, मैं 2 को नहीं निकालना चाहता हूँ. Let me not take out 2. So this will be integral 2 sine theta cos theta d theta divided by sigma 2 pi r square integral of cos theta d theta. Okay, please see my steps because मैं हमेशा गलती करते रहता हूँ, तो you have to be vigilant. पाई कैंसिल हो गया, सिग्मा कैंसिल हो गया, आर स्क्वायर कैंसिल हो गया. Now for the limits of integration. So for this guy, for this ring, यहाँ पे I've already made the diagram. For this ring, theta is equal to 0, and for this guy, theta is equal to 90 degrees. So the limits of integration are from 0 to 90. 0 to 90. So this tells us this will be equal to r by 2 integral of sine 2 theta d theta 0 to 90 divided by integral of cos theta d theta 0 to 90. So this will be r by 2. Anybody remember what is the integral of sine 2 theta d theta? बहुत साल पहले जब हम इंटीग्रेशन किया करते थे. और ये अभिजीत गलत आंसर, नहीं सही आंसर, सॉरी सही आंसर. So this will be equal to minus cos 2 theta upon 2। नहीं राधिका, आपने उसको डिफरेंशिएट कर दिया। डिवाइडेड बाय cos थीटा का इंटीग्रेशन क्या होता है? cos थीटा का इंटीग्रेशन क्या होता है? व्हाट इज द इंटीग्रेशन ऑफ cos थीटा? वेरी गुड अपेनियस। sin थीटा 0 to pi by 2, 0 to pi by 2। Please tell me the final answer। हाँ अभिजीत, वो नहीं आएगा ना, क्योंकि ये नहीं है, थोड़ा गलत, थोड़ी सी गलती करी है, तब थोड़ा सिली मिस्टेक किया है, कुछ नहीं। cos पाई की वैल्यू -1 होती है और cos 0 की वैल्यू 1 होती है। नहीं राधिका, सिली मिस्टेक बहुत गई। सिली मिस्टेक जो है, cos पाई की वैल्यू -1 होती है। वेरी गुड शाबाश, यस। नहीं साइन, सिली मिस्टेक, अगेन सिली मिस्टेक, छोटी सी गलती कर रहे हैं आप लोग। जब -cos 2 थीटा बाई 2 में पाई बाई 2 डालेंगे तो +½ मिलेगा। नहीं, अथर्व गलत है, सिली मिस्टेक कर रहे हैं आप। -cos थीटा बाई 2 में जब पाई बाई 2 डालेंगे तो +½ मिलेगा, और जब -cos 2 थीटा बाई 2 में 0 डालेंगे तो -½ मिलेगा। हाँ सोनल, सही। -cos 2 थीटा बाई 2 में पाई बाई 2 जब पुट करेंगे तो हमको +½ मिलेगा, और -cos थीटा बाई 2 में जब 0 पुट करेंगे तो -½ मिलेगा। We will get ½ minus -½ that is ½ plus ½, that is 1। 1 in the numerator, और डिनोमिनेटर में sin पाई बाई 2 1 होता है। We will get 1 upon 1, so the answer will be r by 2। ठीक है। नंबर 4, सिग्मा तब यूज करते हैं जब हमारा ऑब्जेक्ट का वॉल्यूम ना हो। रो तब यूज करते हैं जब ऑब्जेक्ट का वॉल्यूम हो। तो एक हॉलो हेमिस्फीयर या हॉलो स्फीयर का वॉल्यूम नहीं होएगा। रिमेंबर, वो एक पेंट के शेल है ना, हॉलो हेमिस्फीयर या हॉलो स्फीयर तो पेंट का शेल है ना, उसका वॉल्यूम नहीं होगा, उसका केवल एरिया होगा। सेंटर ऑफ मास ऑफ सॉलिड हेमिस्फीयर of radius. So try and do this by yourselves. We will discuss this in the next class. Please take screenshots. So this is the first screen where we try to find the center of mass of a half disk. And यहाँ पे actually हम लोगों ने निकाला नहीं है, but I have shown you what elements not to take. Please take a screenshot. Second, very, very important. Very, very important. Please take a screenshot. Third, we have found the center of mass of a half ring, radius r. Okay. Please try to do this again by yourselves. HCV में anyways question है इसके. Then we found the center of mass of a spherical shell. Please take a screenshot. So this thing, please take a screenshot of this, is to be added to the second slide. Okay, this is to be added to this slide. तो यहाँ पे मैंने डिस्क और स्फीयर का किया है, लेकिन अगर हॉलो स्फीयर होएगा या हॉलो हेमिस्फीयर होएगा तो ऐसे इसको करते हैं. प्लीज टेक अ स्क्रीनशॉट. And if you are confused about the limits, I hope this cleared it up. Please take a screenshot of this. Okay, so you have to find for me the center of mass of a solid hemisphere of radius r. We will discuss this in the next class. ठीक है? Please go through this material again. This is extremely new and extremely dense material. You need to wrap your head around it, and to do that, you need to do it again and again. If you can do it a couple of times, derive the center of mass of all the objects a couple of times, that should be good. हाँ, तो वही जो है वही प्रैक्टिस से आएगा. करो HCV, प्रैक्टिस से आएगा. चलो guys, okay? We'll meet in the next class. Zeal. चलो, bye bye.